Hi, my name is Emily Leal, and for this teaching demonstration, my topic is central limits theorem. So what that is it states that the sampling distribution of the sample means approaches a normal distribution as the sample size gets larger, no matter what the shape of the population distribution is. So that's the definition. And for this teaching demonstration, I will be explaining what the central limits theorem is, how I use it in everyday life, and I will also show you an application problem that I constructed. So looking at research, I found these facts. So the central limits theorem involves the sampling distribution of the mean. And the mean of the sample is this symbol with an X with a bar on top. The size of the sample is shown with the variable n. The standard deviation of the sample is shown with the variable s. And these are all the symbols that you will be using whenever you are doing a problem using the central limit theorem. I found 4 aspects of the central limit theorem. The first aspect is the sampling distribution of the mean will be less spread than the values of the population sample is drawn. The second aspect is the sampling distribution will be modeled by a normal distribution. The third aspect is the spread of the sampling distribution is related to the spread of the population values. And the final aspect is bigger samples will lead to a smaller spread in the sampling distribution. So all of these aspects really tie in what the central limit theorem is and what it is used for. Now, some examples for how you use the central limit theorem in everyday life. You can use it to solve real-life challenges that occur in businesses, or you can use it to solve problems in physics, psychology, economics, etc., with it being one of the most widely used theorems in stats. Another example is I found pollers attempting to guess how an election will turn out due to the central limit theorem giving us a specific distribution over our estimates. So using the central limit theorem will give you a much more proper and decisive answer versus using estimates or guessing. The type of reasoning the central limit theorem gives us is used in almost every single poll, survey, trial, study, and random experiments, and any other sort of research imaginable. So an application problem I researched. So the first part of it is you start with the mean, and this problem can be based off of a teacher's salary. So the mean is 58,200, the standard deviation is 6,750, and the probability is x is greater than or equal to 50,000. So here I drew my little bell-shaped image, and I put the mean right in the middle, and over here I wrote the probability. And to solve the z-scores, you use the z equals x minus mean divided by the standard deviation. And I plugged in all the numbers that I had, and I got this z-score. And when you use the z-score table, it only shows from this line over. So what you have to do is find the area of this, and you subtract it by 1, which gives you the z-score needed for this side. The second part to this problem is you use a different z-score problem. So you change, instead of the standard deviation, you get the sample size that you are picking from. So this sample size, I chose 100. So over here, you have to find sample size. So s equals standard deviation over square root n. So this is the same standard deviation with the 100 sample, which gives us 675. So you plug that in with this problem over here, and using the same numbers as you got and with the answer you got over here, which gives you this z-score, which is a very big drastic change from this one to that one. And as you can see with the second bell shape, you put the mean in the same spot right in the middle. But because of the big difference of this one and that one, you